The cosine of the direction angles alpha, beta and gamma is denoted as cos alpha, cos beta and cos gamma. They are called as the direction cosines. Any three numbers which are proportional to the direction cosines of the line are called the direction ratios of the line. Whenever a line is on the x-axis, it makes an angle of 0 degrees, 90 degrees and 90 degrees. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now in this session I am going to discuss regarding the new chapter, that is three-dimensional geometry, 3D geometry. This is very important chapter and very easiest chapter. So the chapter 11, that is three-dimensional geometry. Now let us know what are the things we are going to study and what is the weightage for this chapter. So the weightage for this chapter is, you will get one 1-mark question and one 2-mark question and one 3-mark question and one 5-mark question. So all the questions 1 mark, 2 marks, 3 mark and 5-mark questions you are going to get, except 4 and 6. This is very important, and the total mark for this is 11 marks. So 1-mark question you will get. So and a 2 marks question, one 2 marks question and 3 marks. So usually 2 and 3 marks questions are from problem based questions, and the 5 marks question is definitely a derivation from equation of a line or equation of a plane, and totally you are going to get 11 marks from this. Okay, now let us see what we are going to discuss in this chapter. What are the contents, what are the topics we are going to discuss in this chapter. So in this chapter we are going to discuss, we shall study the direction cosine and the direction ratios of a line first, direction cosines first, DCS, direction cosines, and the direction ratios. Direction ratios we are going to study. The cosines, direction cosines and the direction ratios of a line joining the 2 point. And also we will discuss regarding the equation of lines, different form of equation of lines and equation of place in the space. So in this section we are going to discuss regarding the derivation of different equations of the line and equations of the plane in space under different conditions. Again further, the angle between the two lines and the angle between the two planes, a line and a plane, and the shortest distance between the two skew lines and the distance of a point from a plane. These are the things we are going to study. So here in this section, in this chapter, we are going to study regarding the direction cosines and directions line of a joint line, direction ratios and direction cosines of a line joining the 2 points, and also we will discuss about the equation of the line and plane in space under different conditions, and also angle between the two lines and two planes, a line and a plane, that is the angle between two lines, two planes, a line and a plane, and the shortest distance between two skew lines and the distance of a point from a plane. These are the things which we are going to study in this chapter. Now let us discuss regarding the direction cosines and the direction ratios. Now let us consider the direction cosines and direction ratio. Let us know what is meant by a direction cosine and direction ratio. Suppose if a line L is passing through the origin, this is the line L, a line L passing through the origin makes an angle alpha, beta, gamma with positive direction of x-axis, y-axis and z-axis. If a line L passes through the origin and makes an angle of alpha, beta and gamma with the positive direction of x-axis, this is alpha and this is beta, the angle between x-axis and the line is alpha, this is beta, angle beta, and the angle between the line L and the z-axis is gamma. This is gamma, this is beta, and this is equal to alpha. So if a line passes through the origin, makes an angle alpha, beta, gamma with positive direction of x-axis, y-axis and z-axis, x, y and z-axis respectively, then are called the direction angles. They are called as the direction angle, and the cosine of these direction angles, namely cos alpha, cos beta and cos gamma, are called as the direction cosine. So the cosine of these direction angles, the cosine of the direction angles alpha, beta and gamma is denoted as cos alpha, cos beta and cos gamma. They are called as the direction cosines, and these direction cosines are denoted as L, M and N. So therefore L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. Therefore this L, M, N, cos alpha, cos beta, cos gamma are called the direction cosines of a line. Followed? So this is very important. Suppose if a line L passes from the origin, makes an angle alpha, beta, gamma with the positive direction of x-axis, y-axis and z-axis. This is alpha, beta and gamma. Then this alpha, beta, gamma are called direction angles, and the cosine of these direction angles are called the direction cosines. That is, cos alpha, cos beta, cos gamma are called the direction cosines, denoted as L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma are called the direction cosines of the directed line L. These are called the direction cosines of the line L. Now, any three numbers which are proportional to the direction cosines of a line are called the direction ratios. Any three numbers which are proportional to the direction cosines of the line are called the direction ratios of the line. Suppose if L, M, N are the direction cosines and A, B, C are direction ratios of a line L, then A is equal to lambda into L, B is equal to lambda into M and C is equal to lambda into N for any non-zero lambda belongs to the real number. Now, so therefore this A, B, C are called the direction ratios of a line L, and line L, capital N. L, M and N are called the direction cosines. So A, B, C are called the direction ratios, L, M, N are called the direction cosines. So therefore the relation between these direction ratios and the direction cosines are L by A is equal to M by B is equal to N by C is equal to a constant, where K is a constant. So if L by A is equal to M by B is equal to N by C, therefore if we consider L by A is equal to K, cross multiplied, we will get L is equal to K into A, or L is equal to A into K. L is equal to A into K, and similarly M is equal to B into K and N is equal to C into K. Okay. Now from this we are going to get the relation between the direction cosines of a line. Now consider a line RS with a direction cosines L, M and N. So consider a line RS and the direction cosines for this line is L, M, N. Then through the origin, from this origin a line is drawn which is parallel to RS. From the origin, through the origin, a line OQ is drawn which is parallel to RS. The line is drawn parallel to the given line and makes the point P, X, Y, Z on the line. Okay. Now, from P, draw a perpendicular to PA. From this point, this is the perpendicular. A perpendicular is drawn to PA on the x-axis. Let this distance O to P is equal to R. If OP is equal to R and OA is equal to X, then we have cos alpha, cosine of alpha, cos alpha is equal to cos theta is nothing but adjacent by hypotenuse, that is OA divided by OP. OA is equal to X and OP is equal to R. Cos alpha is equal to OA by OP is X by R. So cos alpha is X by R. So this gives X is equal to L into R. So cos alpha, that is nothing but L, is equal to X by R. Therefore, if we cross multiply, what you are going to get? X is equal to L into R. Similarly, we will get Y is equal to M into R and Z is equal to N into R. Okay. Now similarly, X is equal to LR, Y is equal to MR, N is equal to ZR. Now therefore, this can also be written as what we got? X is equal to LR, Y is equal to M into R, X, Y and Z is equal to L, M and N into R. So from this, Y is equal to MR and Z is equal to N into R. From this we are going to get the relation between the direction cosines of a line. Okay. Any three numbers which are proportional to the direction cosines of a line are called the direction ratios. Any three numbers, small a, small b, small c, which are proportional to the direction cosines of a line are called as the direction ratios. Direction ratios of the line. So if L, M, N are the direction cosines of the cosines and A, B, C are the direction ratios of a line, then A is equal to lambda into L, B is equal to lambda into M, and C is equal to lambda into N. That is, any three numbers which are proportional to the direction cosines, any three numbers which are proportional, A is proportional to the direction cosines cos alpha, A is proportional to cos alpha, B is proportional to cos gamma, and C is proportional to cos, A is proportional to cos alpha, B is proportional to cos beta, and C is proportional to cos gamma. This implies A is equal to a constant into cos alpha. Since this can be written as K into, what is cos alpha? Cos alpha is equal to L, cos beta is equal to M, cos gamma is equal to, so therefore we will get A is equal to K into L, or A is equal to lambda into L. Similarly, B is equal to lambda into M, and C is equal to lambda into N. A is equal to lambda L, B is equal to lambda N, or C is equal to lambda into N, or you can take K, KL, Km and Kn, where lambda and K are a constant, non-zero real numbers. Now let A, B, C be the direction ratios of a line L, M, and N, and ABC are the direction, let ABC be the direction ratios of the line, and L, M, N are the direction cosines of the line. Then we have this relation from this L by S, A by L is equal to lambda, or you can also write L by A is equal to M by B is equal to N by C implies K. That is, L by A is equal to M by B is equal to N by C is equal to K. K is a constant. Or if you take L by A is equal to M, L by A is equal to K implies L is equal to K into A. Similarly, we have M is equal to B into K and N is equal to C into K. Now let us find out the value of L square plus M square plus N square. We know that L square plus M square plus N square is always equal to 1. Now since L square plus M square plus N square is equal to 1, substitute here. What is L? A square K square. This is A square K square. M, B square K square plus C square K square is equal to 1. You can take K square common factor, K square out, A square plus B square plus C square is equal to 1, or only K square can be written as 1 divided by A square plus B square plus C square, or the value of K, only K is equal to plus or minus 1 over square root of A square plus B square plus C square. What is K here? K is equal to plus or minus 1 by root of A square plus B square plus C square is the value of K. Now, therefore, if A, B, C are the direction ratios, then the direction cosines of the line L, M, N are given by, what is L? L is equal to A by K. What is K? K is equal to plus or minus A by root of A square plus B square plus C square. So, L is equal to plus or minus A by root of A square plus B square plus C square. M is equal to plus or minus B by root of A square plus B square plus C square. And N is equal to plus or minus C by root of A square plus B square plus C square. Therefore, the direction cosines, whenever the direction ratios are given, is L is equal to, I'll rub this and I'll write here. Therefore, the direction cosines L, M, N are given by L, M, N are equal to, what is L? A plus or minus A by K. K is equal to root of A square plus B square plus C square, comma M is plus or minus B by root of A square plus B square plus C square, comma plus or minus C by root of A square plus B square plus C square. See, these are called the direction cosines. Okay. So, if A, B, C are the direction ratios, then the direction cosines L, M, N are given by A by root of A square plus B square plus C square, comma, plus or minus b by root of a square plus b square plus c square, comma, plus or minus c by root of a square plus b square plus c square. So in general, if alpha, beta, gamma are the direction angles, then the direction cosines are cos alpha, cos beta, cos gamma, denoted as L, M and N. L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. Followed. Suppose if A comma B comma C are the direction ratios, A, B, C are the direction ratios, then the direction cosines are given by L, M, N. L, M, N is equal to plus or minus A by root of A square plus B square plus C square, comma, plus or minus B by root of A square plus B square plus C square, comma, plus or minus C by root of A square plus B square plus C square. That's it. That is a simple concept which you have to be remembered. Now, let us come to this relation between the direction cosines of a line. Now, consider a line RS. This is the line. Let us consider a line RS with the direction cosines L, M and N. So, the direction cosines of the line RS is L, M, N. Now, let us consider a line RS or S, a line which passes through R and S, RS whose direction cosines are L, M and N. Then, through the origin, draw a line which is parallel to RS. From origin, OP is drawn, a line OP is drawn from the origin which is parallel to the RS, which is parallel to the line RS, parallel to the line RS, and it will make a point PXYZ on the line. Let PXYZ be any point on the line. Now, join this AP. Join, AP is joined. Now, then let P from P. So, from P, from this point P, draw a perpendicular PA. This is the perpendicular. This PA is the perpendicular. From P, a perpendicular PA is drawn on this x-axis. Okay. So, therefore, the distance OP is equal to R. This is equal to R. Now, here OP is equal to R from this triangle. OPA from triangle OPA. So, OP is equal to R and OA is equal to X. This OA is equal to X coordinate alpha. Then, the cosine of alpha is given by cos alpha is equal to adjacent by hypotenuse, that is OA divided by OP. OA divided by OP, cos alpha is equal to OA divided by OP. What is OA? X divided by R. So, cos alpha is equal to X by R. So, therefore, cos alpha is equal to X by R. What is cos alpha? L. L is equal to X by R, which implies X is equal to L into R. X is equal to L into R. Similarly, we have Y is equal to M into R and Z is equal to N into R. So, I will go to the next page. Therefore, X is equal to L into R, Y is equal to M into R, X, Y and Z is equal to N into R. So, Y is MR, Z is equal to NR. Okay. Now, write down the value of X square plus Y square plus Z square. X square plus Y square plus Z square is equal to LR square, L, Y is equal to M into R whole square plus Z is equal to N into R whole square. This is L square R square plus M square R square plus N square R square. So, you can take R square out. What you will get? L square plus M square plus N square. That is X square plus Y square plus Z square. X square plus Y square plus Z square is equal to R square into L square plus X square plus Y square. Since we know the value of X square plus Y square plus Z square is always equal to R square. Since X square plus Y square plus Z square is equal to R square. That is, if I substitute X square plus Y square, therefore, X square plus Y square plus Z square is equal to R square is equal to R square into L square plus M square plus N square. Divide by R square, this R square gets cancelled. 1 is equal to L square plus M square plus N square. So, therefore, L square plus M square plus N square is always equal to 1. This is the relation between the direction cosines of a line. The relation between the direction cosines of a line is given by L square plus m square plus n square is equal to 1. That's it. Very simple concept. That is what we have used in the previous step. Now let us come to the next concept. Direction cosines of a line passing through the 2 points. Now to find the direction cosines, so whenever the direction ratios are given, if A, B, C are the direction ratios, then the direction cosines L is equal to plus or minus A by root of A square plus B square plus C square, plus or minus B by root of A square plus B square plus C square, plus or minus C by root of A square plus B square plus C square. Suppose if a line passes through the 2 points, say x1, y1, z1 and x2, y2, z2, then how to find the direction cosines? So to find the direction cosines of a line passing through the 2 points, suppose this is the line. Suppose, let us write down, this is the axis, origin, x-axis, y-axis and z-axis. Okay. Suppose this is the line PQ. What is P? x1, y1, z1, Q, x2, y2, z2. Suppose if it makes an angle, this is alpha or it is gamma. Let us call it as, on the z-axis it makes an angle gamma. Then, so to find the direction cosines of this line, so to find the direction cosine of a line passing through the 2 points P, x1, y1, z1 and Q, x2, y2, z2. Now let us represent this as n and m. Now from this, right, let us find out cos alpha, cos beta, cos gamma. Since the angle is gamma, I can take cos of gamma, cos theta. What is cos theta? Cos theta is equal to adjacent by hypotenuse. Here adjacent is nothing but NQ and hypotenuse is equal to PQ. So cos gamma is equal to N into Q divided by PQ. What is NQ? NQ is nothing but Z2 minus Z1 divided by PQ. Okay. Similarly, cos alpha can be written as, for cos alpha we will get x2 minus x1 divided by PQ. And for cos alpha and for beta, cos beta, we are going to get y2 minus y1 divided by PQ. What is this PQ? PQ is nothing but the distance between the 2 points. So therefore, using distance formula, you can write PQ is equal to x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So therefore, the direction cosines of a line passing through the 2 points is given by, therefore the direction cosines of the line is L, M, N is always equal to cos alpha, cos beta, cos gamma. What is cos alpha? x2 minus x1 divided by PQ, comma, y2 minus y1 divided by P2Q, comma, Z2 minus Z1 divided by PQ. What is PQ? Where PQ is equal to, PQ is nothing but the distance between the points x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. That's all. So therefore LMN is equal to, I can write like this, LMN can be written as x2 minus x1 divided by root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. Similarly, for this y2 minus y1 by this, z2 minus z1, y2 minus y1 divided by PQ, z2 minus z1 divided by PQ. So this is how we are going to find the direction cosine. So the direction cosines of a line passing through the points x1, y1, z1 and x2, y2, z2 is given by x2 minus x1 divided by PQ, the distance between P and Q, y2 minus y1 divided by the distance PQ, and z2 minus z1 divided by the distance PQ. That's it. So these are the three concepts. So to find the direction cosines when alpha, beta, gamma are given is cos alpha, cos beta, cos gamma, that is LMN. If A, B, C are the direction ratios, then the direction cosines are plus or minus A by root of A square plus B square plus C square, plus or minus b by root of a square plus b square plus c square plus or minus c by root of a square plus b square plus c square. And the third concept is to find the direction cosines of a line passing through the 2 points p x1, y1, z1 and q x2, y2, z2 is L, M, N is equal to x2 minus x1 divided by the length PQ, y2 minus y1 divided by PQ and z2 minus z1 divided by PQ, where PQ is nothing but the distance between P and Q, that is root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. That's all. These are the few concepts, very important basic concepts in this 3D. You might have been studied this in your first PUC also. So the same concept we are studying here. Now, let us take few problems based on these concepts. Now, come to the problems. If a line makes an angle, this is very important for 1 mark. Usually, you will get this type of question for 1 mark. If a line makes 90 degrees, 60 degrees and 30 degrees with the positive direction of x, y and z axis respectively, find the direction cosines. Now, what is the problem? Now, let us come to the solution. What is given? Alpha is equal to 90 degrees, beta is equal to 60 degrees and gamma is equal to 30 degrees. These are the direction angles. Now, what is to find is L, M, N. L, M, N. This is the question mark. L is equal to cos alpha, that is cos of, what is alpha? 90 degrees. So, you know what is the values of this? Sin 90. Sin 0 is 0, sin 91, cos 90 is equal to 0. So, cos 90, this is 0. L, M is equal to cos of beta. What is beta here? Beta is equal to 60 degrees. What is cos 60? You know sin 60. Sin 60, root 3 by 2 and cos 60 is equal to 1 by 2. So, this is equal to 1 by 2. Again, N is equal to cos of gamma. Cos gamma is equal to, what is gamma here? 30 degrees. What is cos 30? So, you know the value of sin 30. Sin 30 is off and cos 30 is equal to root 3 by 2. Okay, this is equal to root 3 by 2. So, therefore, the direction cosines L, M, N are 0, 1 by 2, root 3 by 2. These are the direction cosines. 0, 1 by 2 and root 3 by 2 are the direction cosines of a line if it makes an angle of 90 degrees, 60 degrees and 30 degrees. Now, if you want to verify, you know the relation. Since we know this, L square plus M square plus N square is equal to 1. Substitute the value, 0 square is 0 plus M square 1 by 2 whole square is 1 by 4. Plus root 3 by 2 whole square is 3 by 4. So, take LCM, 4 is LCM, 1 plus 3 is 4 by 4 is equal to 1. So, L square plus M square plus N square is equal to 1. That's it. Now, next come to the next problem. What is the problem? Same type problem. If a line makes an angle 90 degrees, 135 degrees and 45 degrees with the positive direction of x, y and z axis respectively, find its direction cosine. Same problem. Now, what is given here? Given alpha is equal to 90 degrees, beta is equal to 135 degrees and gamma is equal to 45 degrees. So, therefore, the direction cosines are L is equal to cos alpha, that is cos of, what is alpha? 90 degrees. What is cos 90? Cos 90 is 0. Again, M is equal to cos beta. This is cos of, what is beta? 135 degree. So, 135 can also be, this is an allied angle. You can write this as 90 plus 45. What is cos 90 plus 45? Minus sin 45. This is in second quadrant. Cos is negative. Minus 1 by root 2. Cos 45 is 1 by root 2. And L, M and N is equal to cos gamma. This is cos of, what is gamma here? 45 degrees. What is 45? Cos 45 is 1 by root 2. So, therefore, the direction cosines L, M, N or L is 0, M is minus 1 by root 2 and N is 1 by root 2. That's it. See, L cos alpha cos 90 is 0, M cos beta cos of 135, cos 135 can be written as cos 90 plus 45. 90 plus cos 90 plus theta is minus sin theta, minus sin 45 minus 1 by root 2. Again cos gamma, cos 45 is 1 by root 2. So the direction cosines are 1 L M N are 0 comma minus 1 by root 2 comma 1 by root 2. If you want, you can verify it. L square plus M square plus N square is equal to 1. So L square plus M square plus N square is equal to 1. 0 square is 0. 1 minus into minus plus 1 by root 2 square is 1 by 2. Again 1 by root 2 square is 1 by 2. Half plus half is 1 is equal to 1. That's it. Okay, followed. This is very simple and very important problem for 1 mark. Simple problem. Now let us come to the next type of problem. This is very important for 2 marks. This is a 2-marker question. Very important. Find the direction cosines of a line which makes direction cosines. What is required to find is cos alpha, cos beta, cos gamma, that is L, M and N, which makes equal angles. The angles are equal with the coordinate angle. Equal angle with x-axis, y-axis and z-axis means alpha, beta, gamma are equal. Alpha is equal to beta is equal to gamma. That's it. So what is given here? Given if alpha, beta, gamma are the angles made by x-axis, comma, y-axis and z-axis. Given that, what is given? Alpha is equal to beta is equal to gamma. This is the given condition. Alpha equal angles means alpha is equal to beta is equal to gamma. So therefore, L is equal to cos alpha, M is equal to cos beta implies alpha is also equal to beta. This is cos alpha. Again L, M, N is cos gamma. Gamma is also equal to alpha. So L is equal to cos alpha, M is equal to cos alpha, N is also equal to cos alpha. Since we know the relation L square plus M square plus N square is always equal to 1. Substitute the value. What is L? L is cos alpha. This is cos square alpha. M is also cos alpha, cos square alpha. N is also alpha. Cos square alpha is equal to 1. So cos square alpha plus cos square alpha plus cos square alpha is 3 cos square alpha. 3 times cos square alpha is equal to 1, or only cos square alpha is equal to 1 by 3. Therefore, cos alpha is equal to plus or minus 1 by root 3. Cos alpha is equal to plus or minus 1 by root 3. So, what is this? Substitute here. Cos alpha is equal to 1 by root 3. Cos beta is also equal to 1 by root 3. Cos gamma is also equal to 1 by root 3. So, therefore, L, M, N are plus or minus 1 by root 3, comma, plus or minus 1 by root 3, plus or minus. So, these are the direction cosines of a line which makes equal angle with the coordinate axis. Very important problem. So, the direction cosines of a line which makes equal angle with the coordinate axis is L, M, N is equal to plus or minus 1 by root 3. 1 by root 3, 1 by root 3, 1 by root. That's it. So, this is very simple problem. See here, if alpha, beta, gamma are equal, alpha is equal to beta is equal to gamma. Let us say alpha, beta, gamma is equal to alpha. L is equal to cos alpha. M is also cos alpha. N is also cos alpha. Since we know that L square plus M square plus N square is equal to 1. Cos square alpha plus cos square alpha plus cos square alpha is equal to 1. 3 cos square alpha is equal to 1. Cos square alpha is equal to 1 by 3. Cos alpha is equal to plus or minus 1 by root 3. So, therefore, L is equal to M is equal to N is equal to plus or minus 1 by root 3. So, it makes 1 by root 3 if alpha, beta, gamma are equal. Now, let us come to the next problem. Find the direction cosines of x, y and z axis. This is also a very important problem. So, usually you will get this for 1 mark question. This is again a 1 marker question. Find the direction cosines of x, y and z axis. Now, let us come to the first one, x axis. Here, a line in the x-axis makes an angle of, so in the x-axis it makes an angle of 0 degrees, 90 degrees and 90 degrees. Whenever a line is on the x-axis, it makes an angle of 0 degrees, 90 degrees and 90 degrees. So, therefore, L, M, N is equal to cos 0, cos 90 and cos 90. What is this equal to? This is equal to sin 0, 0, cos 0 is 1, cos 90 is 0, 0. So, the direction cosines on the x-axis is 1, 0, 0. This is very important. Just if you write the direction cosines of the line on the x-axis is 1, 0, 0, you will get 1 marks. That's it. Hope you followed. The direction cosines on the x-axis is 1, 0, 0. Now, similarly, the direction cosines on y-axis. On y-axis, it makes an angle. It makes an angles of 90 degrees, 0 and 90 degrees. So, therefore, L, M, N are cos 90, cos 0 degrees, cos 90 degrees. This is nothing but what is cos 90? 0, 1 and 0. So, the direction cosines on the y-axis is 0, 1, 0. Similarly, on the z-axis. So, it makes an angles. What are the angles? It makes an angles of 90 degrees, 90 degrees and 0 degrees. So, therefore, L, M, N are cos 90, cos 90, cos of 0 degrees. So, this is equal to 0, 0 and 1. So, therefore, in general, the direction cosines on x-axis is 1, 0, 0. On the y-axis is 0, 1, 0. On the z-axis it is 0, 0, 1. If you remember this much, so you will get any one. For 1 marks they may ask x-axis, y-axis or z-axis. On the x-axis 1, 0, 0. Y-axis 0, 1, 0. On the z-axis 0, 0, 1. That's it. Okay. Now let us come to the next problem. Now this is very simple problem. If a line has direction ratios, the direction ratios are given. A, B, C are given. Determine the direction cosines. Now what is given here? Given that A, direction cosine A is equal to 2, B is equal to -1, C is equal to -2. These are the direction ratios. Now what is to find the direction cosines? The direction cosines are L, M, N is equal to plus or minus A by root of A square plus B square plus C square plus or minus B by root of A square plus B square plus C square, plus or minus C by root of A square plus B square plus C square. Now find out the value of root of A square plus B square plus C square. So what is this equal to? A square, 2 square is 4 plus B square, 1 square is 1, again 2 square is 4. So this is equal to 9. Square root of 9 is 3. The direction, therefore, the direction cosines L, M, N is equal to, what is A? A is 2 by root of x square, A square plus B square plus C square is 3. 2 by 3, B minus 1 by 3 and minus 2 by. So these are the direction cosines. So 2 by 3 comma minus 1 by 3 comma minus 2 by 3 are the direction cosines of the line having the direction ratios 2 comma minus 1 comma minus 2. Okay. Now let us come to the next problem. What is the next problem? So now you got an idea how to find the direction cosines whenever alpha, beta, gamma are given, and how to find the direction cosines whenever the ratios are given. Now how to find the direction cosines if it passes through the 2 points. Now find the direction cosines of the line passing through the 2 points. These are the 2 points. Now let us consider this as A. A is equal to -2, 4, -5 and B. B is equal to 1, 2, 3. Now find out the distance between these two first. AB is equal to root of -2 -1 whole square plus this is x1, y1, z1. This is x2, y2, z2. x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. This is equal to -3 square plus 2 square plus -8 square. 3 square is 9 2 square is 4, 8 8s are 64. This is equal to 64 plus 4 is 68, 68 plus 9 is 77. This is equal to 77. Now, therefore, the direction cosines are L, M, N is equal to x2 minus x1 divided by AB, y2 minus y1 divided by AB, comma z2 minus z1 divided by AB. Okay, so therefore the direction cosines, I'll go to the next page. Therefore, L, M, N is equal to x2 minus x1 divided by AB, comma y2 minus y1 divided by AB, comma z2 minus z1 divided by AB. Now, what is here? A. What is A? Minus 2, 4, 5. B. 1, 2, 3. x1, y1, z1, x2, y2, z2. This is x2 minus x1. 1 minus of minus 2. 1 minus into minus plus 2 divided by AB is root 77. Y2, 2 minus 4 divided by root of 77, comma 3 minus into minus plus 3 plus 5 by root of 77. So, this is equal to 2 plus 1 is 3 by root 77 minus 2 by root 77, 8 by root 77. So, these are the direction cosines. That's it. Followed. So, to find the direction cosines, whenever 2 points are given, x2 minus x1 by distance between the 2 points, x2 minus x1 by AB or PQ, y2 minus y1 by AB, z2 minus z1 by, so you will get L is equal to 3 by root 77, M is equal to minus 2 by root 77, L, M and N is equal to 8 by root 77. If you want, you can verify L square plus M square plus N square is always equal to 1, you will get, that's it. Okay, hope you followed. These are few basic problems in this 3D geometry. In the next session, we are going to discuss different concepts. Thank you very much.